Okay, so now that we've finished our unit on solving quadratic equations, we're going to take a look at graphing quadratic functions. Okay, so the difference between an equation and a function is that your equations look something like this. Okay, I've got two sides of an equation, and I've only got one variable. So here we can put another x in there. So I could go ahead and try and solve this equation for x. A function is where you've got two variables where you can put a number in for one and get all the others. So when I look at this, this is really signifying a shape for any x and all those y's that come out when I put any x in. So here I would just go ahead and solve for one variable, and that would tell me what my answer is, or my solution for x is, and solve the equation. Whereas this one, it's saying for any x that I decide to input in, I'll find the right y out if I put it into this equation. It'll give me one distinct shape. Okay, so let's remember that a function has input values. So those input are x values. Okay, input is kind of associated with x. It's associated with what's called domain. Okay, what else can we put in? Input goes with that. And also what's called your independent variable. Okay, our output values are associated with the y variable, usually, or the y-axis, the range, and are also called our dependent variables. Okay, so our y values are dependent upon what happens to x. Okay, so a quadratic function, when we go and see a quadratic function and we see that collection of x and y values, those ordered pairs, it's going to produce a graph called a parabola. Okay, so we're going to spend most of this unit trying to pick a parabola apart and find its pieces and be able to graph one from an equation and make an equation from the graph. So let's take a look at an example here. So it says, given the quadratic function, complete the table, plot the points, and draw the graph of the function. So here we go. So here is our x value, or our independent variable, or our input. Okay? And our output here, or our y value, our dependent variable, is what we're trying to find. So we're going to make some ordered pairs here with the graph. So I'm going to go in and put minus 3 in for where I see x. Okay, so x is here, so I put minus 3 as x, so here it goes. And I'm just going to put it into the equation as it is. So minus 3 squared minus 4 is going to give me the right output. So that's going to give me, looks like 9. Minus 3 squared is 9 minus 4, gives me 5. So my ordered pair here, what that gives me is the ordered pair negative 3 and plus 5. Okay, so that's a point on this graph. Here's my x-axis and here's my y-axis. So the one point on this function is negative 3 and 5. So negative 3, 1, 2, 3, and 1, 2, 3, 4, and 5 is right there. Okay, so there we've got 1 point. So let's keep going. Negative 2 squared is going to give me 4 minus 4 is equal to 0. So that gives me the ordered pair negative 2 and 0. Negative 2 and 0. Looks like it goes here someplace. So this is the x and this is the y. Okay, so 1 squared gives me 1 minus 4 is equal to minus 3. So my ordered pair there is going to be negative 1. Oh, I'm going to run out of the room here. Negative 1 and negative 3. I'll put it down here. Negative 1 and negative 3. Okay, so negative 1 and negative 3 is here. Okay, 0 goes into here. So 0 squared minus 4 gives me minus 4. So my ordered pair there is going to be 0 and minus 4. Okay, so 0 and minus 4 looks like it's here. Okay, 1 goes in. and 4 comes out. And look at this. Something kind of neat happens here. That's going to give me minus 3. And look, we got one of those already. We already had minus 3 up here, and this is going to give me another minus 3 value. So at 1 also, my y is minus 3. So at plus 1, I've kind of got these two side by side, right? Okay, 2 goes in, sure enough, same thing. I've got the same pair here as I did, or the same equation here as I did up here, so that's going to give me the same value of 0. So I'm going to get 2 and 0. And one more time. 3 goes in, 3 squared gives me 9. And look at, same thing, right? I get 5 out, whoops, equals 5 out, so my ordered pair is 3 and 5. So 1, 2, 3, 1, 2, 3, 4, 5. So when I go and put these pairs together, or when I go and link up my points here, I get a shape that looks something like this. And this is a parabolic shape. Okay? So a couple of things to know about the equation, though, is that this equation means all the points that would be on this shape. So if I wanted to write in, say we put another table here that said negative 0.5. This function would give me a point that would be at negative 0.5, and it'd be right around there. Okay, so we can put an infinite amount of points into this equation, and it's just going to keep plotting points on our curve. Okay, this means all the points for x that go on y for this equation. Okay, so let's go take a look at this next part here. So a couple of things. There's a couple of pieces of this parabola that we want to point out. So the vertex is where the parabola reaches what's called a maximum or minimum value. So a maximum or minimum value simply means the very highest point or the very lowest point on the graph. So right here, that's as low as this graph goes. Okay, so it kind of squeaks down to a certain spot. Okay, and its minimum point here is going to be at this point. So it looks like where is our lowest point here? Our lowest y value is going to be negative 4, it looks like, right? So right here. So negative 4 is our lowest y value, so that's going to be our minimum value. Okay, in this case 0 and minus 4. Okay, along that vertex is also a line which we're going to call the axis of symmetry. Okay, our axis of symmetry kind of folds one part of the parabola over the other. So if you can imagine this point right here, if I fold it on top across this axis of symmetry, it's going to put that point exactly onto there. And that's what we're talking about here. The points at 3 and negative 3, so 3 and negative 3, those 2 points are exact mirror images of each other. Folds, or here we can also put reflects one part of the graph over the other. So this point is going to reflect over the y-axis to this point to this point, and on and on and on. Okay? So there's a couple of things there. The vertex is at the minimum or maximum value, so we can either have a parabola that looks like this or like this. So here would be a max value, and here's a min. Okay? And our axis of symmetry is simply the line that cuts our parabola in half so that one side will reflect over the other. It's symmetrical, right? Okay? So let's take a look at a couple of examples, see how our algebra is going to pan out over these. Okay? So for each function, find the axis of symmetry, the vertex, and graph it. So here is your magic formula for your axis of symmetry. Okay, that's going to find your line perfectly. So if we have our equation here, which is in standard form, so here's my A, B, and C, just like when we were solving equations. Okay, I can use this formula to find that axis of symmetry. So our axis of symmetry is going to be, for y is equal to x squared graphs, is going to be an x equals line. It's going to mean it's a vertical line, right? Okay, so let's go and use our formula here. And so we're going to use minus b, so minus 4, so x is equal to, our axis of symmetry, is minus 4 all over 2 times 1. Okay, so that gives us, looks like 4 over 2 equals 2. So my line is the line right here, x is equal to 2. So there's x is equal to 2. So I know whatever my parabola looks like, it's going to be symmetrical around that line. This line's going to kind of cut it in half, right? So there's our line, x is equal to x is equal to 2. Okay, so to find the vertex, okay, really we know one thing already. We know a vertex is a point, okay, and we already know one coordinate of that point. We know the x. We know that somewhere along here our vertex is going to be. So I'm going to put 2 here, and how do you think we go ahead and find our y? Okay, well, we can use our formula. So y is equal to, so if I plug 2 in for my x's here, so 2 squared minus 4 times 2 plus 5, that's going to give me my y value. I put x in, and I get y out. Okay, input in, output out. Okay, so here we're going to get 4 minus 8 plus 5. Okay, so 4 minus 8 is minus 4, and plus 5 is going to be plus 1. So at my vertex, I know is going to be at that point right here. Okay, so to graph it, all we really need to do is come up with a couple of extra points on either side of that spot. So let's make a little table here. Okay, so we'll put x and y, and we know that our vertex is at x is equal to 2. So let's pick a couple of points on either side. So here's 3, here's 1. So let's put 1 into our equation. Okay, so if I put 1 in, I'm going to get 1 squared minus 4 plus 5. So 1 minus 4 is minus 3 plus 5 gives me 2. Okay, so we know this one is 1, right? So at plus 1, I've got a point at 2. Okay, and then let's do the same thing with 3. So 3 squared minus 4 times 3 plus 5. That's going to give me, it looks like 9 minus 12 gives me minus 3 plus, well, look at that, plus 5 is equal to 2. And that does exactly what it's supposed to, right? Because this point should be exactly symmetrical around x is equal to 2. So you can kind of see our parabola is going to start this way. So let's put one more in just to be sure. If I put 0 in, well, that's an easy one. 0 minus 0 plus 5 gives me 5. So you should be able to guess 1, 2, 3, 4, 5. Okay, should be able to guess what our symmetrical point will be. Before I even put it into the equation, if I'm looking at my graph, I'm going to guess this point at 1, 2, so we said we're going to put 4 here, right? I'm going to guess that to be as 5 as well, because I can see it's going to be symmetrical around my axis of symmetry, x is equal to 2. So let's see if that happened. Okay, so I'm going to put 4 in, so 4 squared minus 4 times 4 plus 5. Well, 4 squared minus 4 times 4 is the same thing, so 16 minus 16 is 0 plus 5 gives me 5. Okay, and so we can draw our parabola. Okay, so the next one is the same thing. Okay, and I'm going to get you to do that one for an exercise. Except here, just really make sure you're careful about inputting your A's and B's. Okay, so it's the same exact process. You're going to find your axis of symmetry, so find your line. You're going to find the vertex by plugging your x value of your axis of symmetry into the equation and getting a y value out. That'll give you this point here. And then you're going to put that point in the middle of your table and choose a couple of points on either side of it along x, so you can make a couple of more points by dumping them into the equation again. Okay, so a is equal to minus 1, b is equal to 2, c is equal to negative 1, and away you go. So give that one a go before you get to class next time. Cheers!